Microservices. Where did it all go wrong? Ian Cooper. Hello, I'm Chris Tennis. I'm a KMP developer. Tech Sports said they're coming out Tuesday. Close that thing up. I'm going to be doing a watch along with this because I really don't want to watch it all the way, but I'll watch it with you guys. About because I really am not a big fan of the microservices, the whole microservices movement, how hypey it was. It was extremely similar to the AI way. They said all problems are going to be solved as long as you do this microservices stuff. I'm like, yeah, I mean, that sounds pretty good, but like all the monitoring and like figuring out where the transactions are going and seeing all that stuff getting visualization, um, just monitoring it, debugging it, extending it, modifying it, changing it, all the rules of how that stuff puts together. It's very complicated. Just add like a factor of 5 to just a normal mono stack. One a mono app. What's it called? They call it something. What is it? What do they call these things? Yeah, monoliths. Yeah, I mean, most of these things should be monoliths. Most applications should be monoliths. And then there was this big convincing, like, no, you must make it scalable from the start. It was like, I don't know if that's such a good idea to do that way. But let's see what Ian has to say. Give him a like and subscribe as well. I'll leave a link in the doodly-doo.
So in the 1970s, there was a famous Irish footballer, probably one of the first real sporting superstars, called George Best. And George was in a hotel room. He's lying there with a couple of supermodels. There's champagne, traces of cocaine. He's obviously having a wild party. And one of the
I think you've had a wild party, buddy.
staff of the hotel comes in, bringing food and room service. And he looks over at the bed and he says, George, where did it all go wrong? And so this talk, like one of my other talks, is in that spirit of I definitely would be a celebrator of microservices, but I feel that at some points when we look at it, we wonder why perhaps today there's a bit of a backlash against them, a call for us to return to the monolith, etc. So I'm going to try and dig into that.
All right, let's
get into practical help that you can have.
Yeah, because it was definitely oversold by you guys. It was definitely sold as the solution, the way to do. If you weren't doing it, you weren't keeping it. Same thing doing this AI stuff, same hype waves. Like, you must do it this way. It's just someone else's computer, except there's a little bit of APIs between it. Like, we're kind of doing that already. It's like, no, it must be done differently. It's different. It's microservices. It's just kind of like services, but I guess the people were trying to do this distributed thing where they could split these things up, but they were still super coupled. I guess the microservices was like, you should put an API between those things so you can differentiate them. I think that was the main idea, but there was so much hype and confusion and people selling courses and plans and developer revamps and developer revolutions, and it's just like, guys, and then all the tooling that you'd actually need to make that stuff actually work was like 5 to 10 times more work. So you can see all these big companies pushing it because you're going to be running on their machines, or at least trying to, and just getting super confused, wasting lots of time and resources, and having to get help. And we need someone to come in and fix our microservice problem.
That may help you navigate the space. That's a lot of text that you can't read. That's because I'm old. That's really what that says. That's the summary version from ChatGPT. It is old. Are there any .NET developers at this conference? Oh, a few of you. Yay! I work on an open source messaging framework for .NET called Brighter. We compete with Mass Transit and Service Bus. We are actually similar sort of era, right? Okay, what are we going to talk about today? I want to get through some fundamentals and some definitions just so we are all kind of on the same page about the words we're using, because words, unfortunately, in semantic diffusion are at the heart of some of our problem. We'll then go into that problem a little bit. We'll talk about what seems to have gone wrong, and then I will offer you some pragmatic advice. It's 45 minutes, so a lot of that advice will be signposting rather than detail on some of that items. I suspect, given 45 minutes, Q&A will be brief.
Fair enough.
But the first thing I want to do is just run through what we might think of as some fundamental ideas that are important to us. Okay. There is a fundamental theorem of software engineering, and the fundamental theorem was defined by Edward Yordan and Larry Constantine in structure design in 1975. I am sure you all know it. That is the formula, one I'm sure you will recognize and regularly respond to when you're asked about it in an interview.
I've not
Okay.
seen this.
Just for those of you that may temporarily have forgotten the fundamental theory of software engineering, it says, due to complexity, it is always easier and cheaper to create two small pieces rather than one big piece if the two small pieces do the same job as the single piece. This is because combining two problems in one piece forces us to deal with the unneeded interactions between the two pieces.
Only if you know what the two pieces are supposed to do.
So I currently work at Just Eat Takeaway. So we might have, say, for example, the problem of how do I price a basket and how do I assign a courier to do delivery.
I would like to see some studies on this. It seems like a lot. It's like, are you sure? I would like to see some studies about this. Now, the idea for manufacturing, yes, this is obvious. I'm wondering why you need to state it, but when you're applying it to software, what do you mean split? What do you mean complexity? You got to define some of that stuff, and I'm going to need to see a study, sir. Let's keep going.
It's pretty obviously going to be easier for us to solve those in two separate pieces rather than...
Is it? Are you sure? This seems to be the issue with AI is they say, oh, you split it up. Oh, just really? Are you solving the problem by splitting it up? Let's keep going.
One piece and have an unnecessary level of coupling between those two pieces. So you can be more specific about that advice. Specifically, we suggest that the cost of implementing a computer system will be minimized when the parts of the problem are solvable separately. Right?
Oh, wouldn't that be nice? Some of this stuff isn't. Some of this stuff you have to have one person have it all in their head, and then you could break it down maybe into solvable chunks. But then the API is defined between these two things. It has to be like coming from one brain or somebody's idea, some conceptualization that we all agree on. And the delineation between these two things, just like an assembly line, goes from one stage to the other. You might be able to get away with it, but there's no. How do you know they're minimized? I need to see some studies on this, sir.
Two quite distinct problems that you solve, and manageably small. There's a slight.
What does that mean? You have to define some of this. Keep going.
Addendum by Jordan and Constantine to note manageably small. Everyone has a different definition of manageably
Absolutely,
small.
Yes. This is all the problem.
Extent, that is just microservices. In 1975, we pretty much defined what microservices were.
Okay, right? I mean, you're just talking about functions, and you're talking about like breaking things into little pieces that are breakable into the pieces. Some things are not breakable to pieces, but things that are can be as part of the solution. But you're talking about writing the software that way or the solution that way. See, this is where it gets confusing.
Break up a system into smaller pieces where those pieces are solvable separately and manageably small.
So is he talking about the solution that the software is making or the creating of the software? This is where I get confused.
This is 1975. That is how you reduce the cost of doing software development. It's the fundamental theorem.
So it's just a manufacturing process? This is the top level academics are saying, oh, software is just a manufacturing process that they've been doing for 150 years at that point? Come on, man. You gotta be... No, this can't be real. Keep going.
Let's define some other ideas, though, as we get into this and try and we'll figure out where we went wrong. So a module.
No wonder we're having so many problems with software development. No wonder people are thinking a knowledge process is a freaking assembly line, and it's not, man. As much as we want it to be, it's never going to be that. So let's stop trying to make it in that and accept that this is another category of thing. More like writing a book. Can you have a formula for writing a book? Yes, it has an introduction, chapters, and a conclusion and an index. But is that actually telling you how to write a book?
So a module is a lexically contiguous sequence of program statements bounded by boundary elements and having an aggregate identifier, which I can't even say. But the easy version
is that? A bounded contiguous group of statements having a single name which refers to like a fucking function? A function? A program? Okay, let's keep going.
It's a group of statements having a single name by which it can be referred to, right? So we're going to agree that's a definition of a module. So Martin Fowler's got a definition of a software component.
I mean, it could be a function, could be a module, could be a procedure, it could be a program. Like these are so arbitrary. Like, why is the point of this?
Which are things that are independently replaceable and upgradable. So
that makes different. That's something else. That's something else entirely. A component. So in his world, which I've heard components be all kinds of stuff. Things are independently replaceable. Okay, all right, we'll accept that definition. I kind of like that. It's really concise. You could say, can this be swapped out? If it can't be swapped out as a unit, then it's not a component. Okay, that's fair. That makes sense.
You can think about libraries, and you can think about services, and essentially
I can think about functions. I can think about classes. I can think about all. What are you talking about?
Components are modules that are replaceable. Now, replaceable is a key idea. And a service is a component.
On the fly. in general, I mean, the whole thing's replaceable.
Component that exists in its own process. Clients talk to over something, the process communication mechanism, RPC, RESTful calls over HTTP, messaging, etc. Right?
Okay. What is a process? A Linux process? Because when you talk to business people, this word right here could be very large. The whole business is a damn process, right? Clients to talk to over inter-process communication mechanism. Okay, this is very. Again, I don't know how helpful this is. I mean, a service, you could define it in so many different ways. It's I like just Alan Kay's approach to this stuff, which I go into. I'll leave a link to my class, my course, whatever. How to program from the ground up. I like how Alan Kay talks about it. These are just ideas to play with. There's no definite defined things. See, even Martin Fowler's he's using acronyms. He's defining specific technologies. He's not saying it. For example, he's saying, no, this is a service. It has to be at HTTP. It has to do RESTful. And it has to have a messaging. It has to have RPC. Or it has to be one of these characters. But this, etc. What do you mean by etc.? Are you talking about communication technology? Or techniques to transfer data? Or store data? What are you talking about, man? Like this is one of the things I don't like about these software architect guys, is that these terms are either too damn specific to that particular most technology at that particular moment, or they're so vague that they actually have very little meaning. Let's keep going.
So for services to become a component, what that means must be that they have a requirement that they are replaceable. And
Okay,
generally, what we want them to be able to do is
part.
replace that without impacting anything else.
Right. Well, okay, now you changed it. It says they're replaceable, but also can't impact anything? Wait a second. I thought, why are we changing it then?
So module, collection of code with a name. Component is one where effectively I can independently replace that module. And a service is one that essentially runs in its own process. It's a fairly simple set of definitions.
Well, what's a process? You mean a Unix process or a business process? See, it's when you start to switch these terms around and not be really super specific is when it gets a little annoying for me, because I'm going to think about all the things. I'm going to think about the business point of view. I'm going to think about the user point of view. I'm going to think about the developer point of view. I'm going to think about the next guy coming on the project's point of view. I'm thinking about how do I want to deal with this level of problem point of view.
What we're talking about. So James Lewis and Martin Fowler both here went on to define microservices, and arguably what you can think of as microservices are a set of practices for succeeding at this architectural style of building services, where we think about services as things that are replaceable.
Which is really what Alan Kay is talking about. So microservices is what Alan Kay is talking about with his cellular membrane thing. It's the same thing, and it's really not even about the service or what technology is working on or anything. It's about having everything go through an API that's defined, that everyone agrees to. It's the interface. That's the big idea. And having everything going mediated through an interface through messages, and you can't just go in and grab it. So whatever you want to call that, of a cell structure that has a membrane that's basically the API, and that you can only communicate in and out of the API, and this thing has its own structure. Oh, I gotta sneeze. So a lot of these ideas are recycled. They've already been solved before for a long time ago. It's just that we want to do marketing. The people want sales-driven, conference-driven, book-driven. Martin Fowler, obviously book-driven development, conference-driven development, sales-driven. They get you the training. They get you the week developer revamp, the onboarding, the get you up to speed on the microservices. So a lot of it's that stuff, man. A lot of it's that stuff, and it will continue to be that way for a long time. And I respect the game. I respect it, but just I'm gonna call it out and say, hey, you might be hyping it up. You might be hyping this up a little bit. This is too much. Then I respect them though. They developed a really long reputation, but they also gish galloped and get people confused to get them into their sales funnel.
Manageably small and solvable separately.
Okay, smart endpoints and dumb pipes. Okay. I hope he defines what some of these things are. Decentralized governance. What is that even? I don't even know what that means. You have to have all these things to do microservices? Okay, let's keep going.
And of those properties, which are the ones they define in their article, the key ones we might want to think about for the purpose of this talk are componentization via services. That really says nothing other than those definitions we already gave. And the one we'll pick up a bit later that's organized around business capabilities, right? So we'll come back to that one. But the first point you should understand from modules, components, services. And there are some benefits which we suggest happen because of microservices. Strong module boundaries, because that process boundary is stronger than than doing it in process. So our module, if it's
right, if you have it on another machine, it's not going to take up time on your machine. Okay.
Defined as a library, it's fairly easy to kind of like violate that boundary, leading to the big ball of mud. But in theory, it's much harder to violate that boundary if we're actually going to cross a process boundary, right?
For an API, okay.
Independent deployment, because we know that they are independently replaceable. We've said that's one of our characteristics of it being a service, right? And reduce cognitive load.
Right, because it's all behind an API somewhere.
They have code that fits in my head because they are manageably small. Right, and we get some other properties which are important, fault tolerance, etc., but we're not going to talk about today so much. But they have costs, right? As soon as I create separate processes, I do distribution, and that always implies a cost. Some of that cost is operational complexity. I'm going to have to create more build scripts. I'm going to have to think about how I monitor my code. I'm going to have to some kind of inter-process communication, like RPC or messaging.
Right? Yeah.
They're harder to verify, right? I can't probably spin up all of the microservices on my laptop.
Yeah, exactly. These are the issues. This is why these things, the development environments and the development tools are just not designed for this type of application development. It's just not. And this is why we've all looked at it, tried it out. That people tried this out and they were like,
and therefore figure out how to test things end to end. I've got questions about separate databases living in microservices and how I do BI and ML, right? And there are general skill issues. Lots of people come to us knowing how to write a simple website, but have no idea how to write a distributed system. And that tends to lead to this idea we call the microservices premium. You probably shouldn't be using microservices to solve your problems unless you are dealing with problems that are large.
Right. Microservices for really big things that need to scale up and scale down and have teams of people dedicated to each individual service. So it's really following Conway's law. Microservices is really a solution for Conway's law. It's like a hack. It's like a hack on it. And they thought they could solve it with this thing, but it's like it really comes down to someone's gonna know all these things put together, man, and someone's gonna know where it's headed and why, and that has to know with intimate knowledge of the customer and where the market's headed. Holy crap, man!
Okay, the code doesn't fit in your head. People can't manage to think about the amount of code that we've got. We've got probably Amazon has a rule of thumb called the 2 pizza.
This was the thing that Alan Kay was talking about with all of his stuff. Is this particular problem right here? Everything in your head you can't keep in your head. You shouldn't be expected to. And the thing is, that's what people were expecting. So you're expecting this superhuman effort as doing normal and replicatable. It's like, no, man.
Pizza team, which basically is the maximum size for a team. One takes about 5 pizzas to feed everybody.
Okay, that's an Amazon thing.
Probably you're a bit, and they're large American pizzas, not our small European. We have, we have cents pizzas.
Oh my God! So everyone's got their own pizza style. So that's even a thing. It's like this is an American idiom. It's not meant for you guys. How about just give the number 5 to 7?
The subdomains have very different forces for change. So in other words,
it's like, oh, it's a pizza team. We're a pizza team. We're pretty big pizza eaters around here. So we got 8 people on our team. Yeah. It's like, come on, stop with that crap.
You've got something like, network busyness as a domain versus pricing your basket, right? Those two things don't change for the same reason, right? And have a wide range of interactions. So more than just I'm talking to this website, but I've got mobile phones, I've got interop with third parties or other technologies.
Big companies.
So all of those complexity factors begin to trigger microservices.
Which they kind of are doing already, but they're also trying to do monoliths and try to scale up a monolith without it being refactored and rechanged to be working in this way. And when trying to skip over the understandability, the maintainability, the extendability, all they think that just by taking the monolith and breaking it apart, that they're going to get that stuff. It's like, no, man. No, you have to think about how the business operates in this particular environment and these enterprises. They don't. Are you nuts?
Services a solution. If you don't have those, then that premium may not be worth paying. And this is general piece of
advice. And it's a premium. It's a heavy premium. That's why just people get oh my God, microservices, I get a big company to do that. It's like, yeah, but you're trying to So what is the right metaphor? You're trying to like tune up a Ferrari or multiple Ferraris using just one wrench. And you're trying to use this one wrench, which works great with one car. It's like, well, that's what you got to do. But now I got to do one wrench on all the cars. You know, there's no automation of this wrenching. They do the Kubernetes. It's like, okay, I have a wrench automator. But then it's like, you're still not based on, still not really, the operating system and the techniques and languages are just really not supporting this whole thing from the bottom up. Like, you can't get it wrong. It's not like you have, it's really hard to get it right. It's like difficult to get it wrong. That's what needed to happen, and that did not happen. We're just like, these companies are like, oh, you're just gonna have a bunch of servers that are just running all the time. Like, yeah, that's not expensive.
Right. Okay. So what's the problem? What's happened? The quote actually is quite useful from John Locke, who was a 16th century philosopher. Parents wonder why the streams are bitter when they themselves poison the fountain. So one of the problems is this word micro, right? So actually at GOTO, Fred George said, if it's more than one programmer to develop and design and maintain, it's not a microservice. They are very, very small. I mean, 100 lines of code is probably a big service these days. And a single function microservices provide us with...
Yeah, I don't know about this, man. Ruby. If it's more than one programmer to develop, it's not a microservice. What? See, these definitions, man. Single function microservices. Okay, so you're talking about lambdas here? Single function microservices. Highest degree of granularity. Man, that's just hard to maintain that stuff. You got to have a whole other set of systems in place. It increases more control of application resource consumption. Yes. Yeah, you can have it, but there's a major trade-off, right? But if you're one of these big companies, it makes sense. But because you got to take that whole cognitive load and break your company apart and do a whole Conway's Law thing, and you have to predict which way you're going to go in the future, and it's good luck getting that right.
With the highest degree of granularity. They increase granularity, give us more control over an application's resource, consumption, availability, and scalability.
Right. You can scale spiky loads up and down. It's great, but like instead of having all those things running all the time, which I'm sure was super expensive, they're all like killed. Like, oh my god, we have to keep 96 servers running at all the times just in case.
The problem, I think, is that micro has less to do with number of lines of code and the need for replaceability.
Yeah.
And that kind of gets misunderstood.
Well, it's really the messaging and the APIs, which is what Alan Kay's been shouting about since the 70s, but nobody listens to him, so... Yeah, he explains it in excruciating days. So then Igor took up the mantle, and he tried his best, but still people are like, no, we have to do this other stuff, and you're just skirting around the issue.
So small is useful in the sense that the bigger something becomes, the harder it gets to replace. But it's replaceability that we care about, not number of lines of code. The problem otherwise is usually described as nanoservices.
Okay.
So I don't know if you've seen these diagrams. Twitter produced one. Monzo, which is a UK challenger bank, produced one. We produced one at some point internally where I am. They look hideous when you have a nanoservices problem. Sometimes people provide them as badges of honor. Look at the amazing world I have to deal with, and all the rest of us look at it and go, look at the horror you've created for yourself. Right?
Yeah, for sure.
So when you get, and quite often the order of magnitude we're talking here is 500, 1,000, 2,000 microservices, right?
Jesus.
When you have that number, you get a huge set of problems.
Oh my god.
Every one of those services has integration points with other services that cross process boundaries, and those are potential points of failure. So if you have 2,000 microservices, you have 2,000 potential points of failure.
Yeah.
You get increased latency if you tend to...
Yeah, if you're doing API calls between everything and you're breaking it down to an API call between every little damn thing. Well, yeah, you're going to have some high latency.
Use an RPC style of interaction, which is typically what happens when you take your monolith and go, oh, there's a class over here and a class over here. I'll make them separate microservices. That's how you do it. And, I'll replace that local function call with a...
This is some hardcore make work. Oh, you just break it up in a billion little pieces and it makes it easier? That's what they told me at the conference. I read this book and it told me just to break everything up into a billion little pieces and that'll make it easy. Let's do it, guys.
Basically with a RPC call, right? And it in turn makes its own function calls.
I love RPC by the way. I love it, but with see, the thing is, this it always gets over. Anytime these new technologies come in, or techniques come on or whatever, new trends, everyone overdoes it. They just take it. They're like, oh my god, it solves all the problems, and all the spurgs and autists like me that have been waiting for something to fix some of the stuff. We take it out, like, okay, we're going to push it all the way to the edge, and we find out, oh, it was never really meant for that. It doesn't really do that. And then we pull back, and we go, crap, we really have to think about this thing at a basic level, bottom-up type of thing. and we don't get to get around. There's no free lunch. We're used to having free lunches, like the Moore's Law. That was a free lunch, but like, I mean, people pay highly for it. But it looks like we get away with all this complexity, and let's keep going.
Well, great. That's RPC calls to the other class that I've now made a microservice, right? So there's a big argument on Twitter at some point during the hell of Twitter becoming X, where someone pointed out that
was it hell? Was it hell for you, buddy? That's sad.
To render your timeline took 64 calls, all kind of made in a chain, and you get huge problems of latency and reliability as soon as you get into that world.
Yeah, for sure, man.
High operational overhead. Every single one of those services is going to generate logs, it's going to generate telemetry, and they're all going to be independent, and you have to find some way of stitching it back together to give yourself a view.
Yeah, that's that monitorability problem, which they're using logs already with monolithic applications. There was terrible. And then you add, that's the monitorability. That was when I found out, oh, okay, wow, they got this microservice. They must have this new visualization tool. You can see all that stuff where the traffic's going, where packets are coming in, things are going around. You'll be able to see that stuff. No, it doesn't exist. You got to roll your own or rent it from somebody. Or to find somebody that writes that so you can see some visualization. And you have to set your system up from the start to work in this way. They're like, no, we're just going to use logs. You're just going to use logs for 2,000 microservices? Are you insane? Pretty good job security, though. Think about that.
Datadog will quite happily take your money to let you do that. It will cost you millions at scale that you will have to pay Datadog to do that. The question
and I wonder where that came from. All this emphasis on got a log. And there's these companies making millions of hundreds of millions of dollars off of ridiculous log statements that no one will ever see. And they're backed up with big, massive data lakes. We got a lot of logs in there.
Really is, did we solve a problem by letting Datadog do that by paying millions for it, or should we not have the problem in the first place?
Yeah, not have the problem in the first place. See, this is why I find some of these things like technology wave things is a little bit of psyop-y. A little bit direct, a little too like not that subtle enough for someone like me to go, hey, wait a second, you're charging people how much for logging? To save their logs just to be able to do what? Well, in case there's a problem, they got a little bit. So that's your visualization on this is a bunch of log statements that take someone who's like expert level at crossword puzzles to put this thing back together, like Rubik's Cube level, super hyper genius. Takes them weeks of scouring over all of this. If this is your solution, no wonder we're like, screw microservices.
They tend to be basically in this form, very synchronous, RPC, temporally coupled. There's no bulkheads to failure. There's contagion. One thing goes down, it takes everything else with it.
Great.
Ironically, for something
that's just totally missing the point.
Where we think, well, I've created lots of little tiny services, surely I have loose coupling. Actually, you tend to have very poor cohesion because anything you want to achieve is actually divided across a large number of touch points, and you have high coupling as a result. You often end up with long release cycles because you end up in a shotgun surgery. Changing anything requires changing huge numbers of microservices.
Yeah, you're totally, so you failed. Anyone that thinks that like you have to do one change like across all the microservices, you have obviously failed at your mission. You're worse off than we just had a monolith. Come on now.
We have some kind of internal discussion about 26 touch points required to do X, right? And the problem it's pointing to is you have effectively fragmented your landscape, and it's no longer possible to solve a given business problem by simply touching one microservice.
Right. Yeah, so that's why a lot of these companies who are still dealing with these issues, they're open for a rapid disruption by narrowing down on a niche and using tools like Campy, where you can have a small number of developers really create solutions that for customers that will take these people because they're not going to be able to respond. They can't respond. Look at what they have to do. I built it on microservices. It's going to be replaceable at will. It's like now you're stuck in a mire tree. Because the way you designed it, and you just went half-cocked and made every class into a microservice. And now everything's all combined and squished together. And you can't move. And we're like, oh, hope somebody doesn't, it's like a deer caught in a trap. It's like, hope somebody doesn't come and take me and make me into lunch and dinner.
And they're a huge obstacle to reasoning. Once you get into 500,000, 2,000 microservices, very few people in the organization have any idea how your system works anymore.
Correct.
And if you can't figure out how it works, it's very hard for you to reason about how you might successfully change it.
No shit.
So there's definitely confusion about micro, right? People are obsessed with size and not with replaceability, but what about services? The problem with services is people have equated that to processes. Now, we defined services earlier, right? And although we talked about a process boundary, it was more to do with, hey, we're using process boundaries to help us effectively to create modules.
All right,
but as soon as you equate that too closely, you get ideas like this. Each service is autonomous and self-contained and runs as a unique process. Each microservice is packaged as a Docker container to enable deployment in a Kubernetes.
That's just a technology. That adds another layer of complexity.
Cluster or application.
May not be necessary to actually do microservices, but you're not really doing it unless you got Docker.
Orchestration. A cloud-native application consists of discrete, reusable components that are known as microservices that are packaged in containers. And in the DevOps community, there is effectively a belief that a microservice is just something that runs in a container. Don't worry, Amazon also has got your back. Launched by AWS, Lambda is all that you need, basically, to build a microservice.
Again, more confusion, more companies building tunnels for sales. I respect the game. I just want to call it out. I respect the game.
Kubernetes, pods, those are microservices, right? Doesn't seem like that's what we originally intended. So, any of you picked up on this? There was a bit of a storm because Amazon Prime Video, located in London, one of their team created a blog post which basically said, we have given up microservices, we've gone to a monolith. People didn't rashly think about the fact that Amazon probably hadn't gone to a monolith, that actually was one team within Amazon, but they'd gone from effectively 2 lambdas and 2 step functions.
I mean, maybe this use case is better than all the confusing shit for 2 monoliths. I mean, for this use case, maybe it would be better just to have a monolith thing that you can spin up and spin down processes that are part of this, but not the main thing. Let's just keep going.
Functions to say, hey, we looked at this problem and we realized it's actually much more efficient if we run ourselves as a single process in Kubernetes.
Yeah, I remember that story.
But the headlines were fairly extreme. It is clear that in practice, microservices propose perhaps the biggest siren song for needlessly...
All right, I had delivery, so I'm going to back this up here in a second.
Much more efficient if we run ourselves as a single process in Kubernetes. But the headlines were fairly extreme. It is clear that in practice, microservices propose perhaps the biggest siren song for needlessly complicating your system. The headline of DHH's post was, even Amazon can't make sense of serverless or microservices, right?
Okay, thank you. Thank you for admitting it, guys.
Which is quite a lot, considering it's one team saying, we got rid of a couple of step functions and we made it a single process. Right. So I love team topologies, but team topologies sometimes seems to exist in a perfect organization where people do sensible...
Talk about team topology, like what is that name of that law? I always forget forget the name of the law. I always forget it's Conway's law. Dang it! Yeah, you can't get around it.
Things rather than kind of reality I live in. So they have this idea of fracture planes. Very useful idea. How do we basically splinter the problem space that we are trying to basically deal with, right, our domain, into a number of pieces? So they have a number of different ways of developing fracture planes. And we'll come to the good way later. But typically I tend to find there's another way they don't talk about, which is team availability, which says, we have a problem to solve. Who's not busy? Okay, they can build a microservice to do that work. And someone goes, but hang on a minute, isn't that just... No, that doesn't matter. It may be a variation of what that team's doing, but it doesn't matter. We'll just build something new over here, right?
I've been at companies that do this. It's like, yeah, I mean, but am I gonna be able to understand the context of the thing I'm working on? No, it's just a microservices. You should be fine. It's like,
and you end up with these services. You go, what? Why do we have an entirely separate service that deals with the hours a restaurant is open compared to the rest of the information, basically, for a restaurant? Because that team is available. So that's the kind of reality you deal with, right? We don't necessarily live in a world where everything is perfect, and that kind of opportunity to use microservices to solve a problem of organizational capacity tends to lead to poor outcomes. So back to structured design in 1975, we had kind of an answer to all this, right? So the idea is, as I essentially increase the number of components and thereby reduce their size, because more components means each one is smaller to solve the same problem, I effectively reduce the number of what's called intra-module dependencies. Those dependencies effectively inside the module. I got less.
This is actually pretty useful. I'm enjoying this.
Lines of code. Obviously, I have less internal dependencies.
This calculation was not made, not mentioned, not talked about when the microservices was introduced. They didn't talk about any of this stuff.
And as I effectively increase the number of components, though, I will increase the number of intermodule dependencies, so the dependencies between things. So the problem we've got a lot with microservices today is people, when they focused on making them small, quite often cross over this point and keep going down.
I guess it's this
one. And what
they're
doing, unfortunately, is increasing the number of intermodule effects.
Right.
And the cost, rather than being at this sweet spot, starts climbing again.
Yeah, so where's the sweet spot? Can an AI tell you what that sweet spot is for your particular solution, for your customers, for this particular thing you're trying to do? It can't. You mean there's going to be a human that has to make that decision? Oh, Jesus.
And maybe for a brief period you were very excited about microservices, but then everyone's complaining about what happened.
Yeah, because you didn't look 3 feet down the road. Hold on here. All right, enough interruptions here. Okay, here we go.
Please remember. All right. Is it fixable? Let me try and offer you some advice.
Why is it that the child sometimes is the opposite of what he's told? Why would a person sometimes dislike receiving a favor? Why is propaganda frequently ineffective in persuading people? And why would the grass in the adjacent pasture appear ever greener? Jack Brem, 1966. Yeah, because these problems that we were having with scaling these things and writing these things and maintaining them and extending them and modifying them and monitoring them and debugging them have become so crazily insane levels of complexity because of how we're building them and what we're building them with and on top of that no one's like taken back. It's like, okay, we have to like rethink what we're trying to do with these machines and build them from the ground up. It's like, well, that's expensive. It's like, well, then we're gonna deal with the other side of like ignoring that. like in dealing with like, oh, it doesn't quite work. It's like when your hair is on fire, you have nothing else. You can't even use you want to use your hands. You don't want to burn your hands. If somebody hands you a brick, you're gonna use that brick. You're gonna bash it against your skull to put your head out. And that's kind of what all these technologies are. It's like business people have these they've got the complexity's gotten away from them. They don't know how to reel it in. They don't really know what's happening. They don't know techniques. They don't want to know how the machine's actually working at the bottom of these tools or these techniques or these technologies are super old. They don't want to know about that stuff. They just wanted to have a quick fix solution where if you just cut your code base up into 10,000 pieces, then you're going to be solving the problems. And that's what they were told. That's what they were sold. That's what they bought. That's what they paid for. That's what they implemented. And then they got something. It's like, why is this a mess with 10,000 microservices that I don't even know? I can't change even one of them because it says cascading problems all the way down. Well, you should have took the advanced course on API design. Back in the sales cycle.
Now, this quote is about the fact that people don't take advice. Some psychologists did a whole lot of work in the 60s, and basically the answer was, don't bother giving anyone advice, they don't like it. But I'll try anyway. All right. So I had a chat on a plane with Chris Simon. There's a link. We'll share the slides sometime after the conference to a talk he did at DevOps. I was coming up from NDC Porto, and he was going back to Australia, but we were both flying back to Gatwick, where he was connecting. Okay. And I was explaining my thoughts about microservices, and I said, I just can't really figure out how to help people here. And he said, I'll just talk about using the 4+1 view to explain how microservices work, and I think that can help you. So we had to chat on the plane, and this talk kind of just generated out that conversation. So
see, you're trying to generalize before you know the problem space. You're trying to generalize a solution space that people can be sold how to do a mechanized process of revamping their broken process and fixing it. No, everyone has to be involved in understanding how these things were put together and work, because that is your business. Your process and how you produce things is your business. In knowledge work, this is the business, not the thing at the end, the providing the service. No, it's the how you get there. And what you emphasize and don't emphasize. Holy smokes, man! Let's keep going.
I want to give a nod to him for this idea of framing it this way. All right, anyone never seen the 4+1 view?
I've heard of it.
4+1 view, it says when we're doing something like software architecture or any form of design, the problem is we're trying to think of it as one way of viewing something. And actually, there are 4 distinct ways we can think about something, right? Logically, development, process, and physical. We'll go with each one in turn. And if you actually think about things in those separate clusters, separate models for achieving different outcomes, it's very helpful. And the problem is often when we talk about something like microservices, we're unclear what we're doing in each one of these steps. So we'll talk about that. Scenarios should be fairly straightforward. So scenarios basically where we're gathering the requirements. This is an example of a technique I quite like called domain storytelling. Domain storytelling to me is a kind of modern version of use cases. I kind of much prefer it to some other techniques that are out there. But what happens is you have actors, people who are doing something, you have work items, things they're doing something with, and activities, what are they doing? And you can kind of with product
Okay, it's like the way to do domain-driven design. Okay, but again, this is a problem space has customers and bloggers and cashiers and shopping carts. Yes, but we can design these as knowledge workers. We can do these things ourselves too. And for the given, we're not going to have a one size fits all. Here's the 10 easy steps, one weird trick to do this stuff. That's not where our value is added. Our value is added. Okay, we can consider these things as just a style, a way, a particular for that particular person that made sense. But for us, We got to do something and think about it, and not just take an off-the-shelf solution and just renovate your whole development team with a week-long course. Got a lot of money in courses this month.
Product owners, etc., easily map out what are the kind of key flows in the system. We also, though, include other kind of scenarios, the technical ones. So this is a chart from something called attribute-driven design, which is like a lightweight form of ATAM. And that's the thing you may hear about people talking about quality attributes, the usability, modifiability, testability of the system. And you define a set of scenarios, in other words, the kind of constraints you want, the non-functional requirements of the system. So both of those are kind of inputs. We're capturing what should the system do.
But you're not going to, but still, some places need this, some places don't.
From a functional and non-functional perspective.
Some projects need it, some projects don't. Some users need it, some users don't. It's more important figuring out what the user wants than all this stuff here. This is good things to think about. Don't get me wrong. He's on the right track here. I appreciate his insights, but it's still trying to. We got a system. We got 4 quadrants, and all you do is do fill 4, and you're good to go. It's like that's part of it, but that's not it.
Right. And usually we start up here at the logical box. And the logical box basically is the functional requirements, what the system should provide in terms of services to its users, decomposed into a set of key abstractions.
Right. The problem space and the solutions that you're delivering, and logical steps, whatever that is.
So I think about this as typically we're thinking about our domain model. What is the problem space? What are we trying to do?
Yeah.
Okay. And when we think about this kind of problem space, that's where what we want to start thinking about is how might I divide the problem space up?
So, right. Like, for an ordering system, it's pretty obvious. You have your catalog of goods, and you have a shopping cart, and then you have the shipping department, and then you have the emailing system and all that stuff. It's kind of not that. It's like it becomes difficult when you're trying to do something else. And where do you break these boundaries up? I mean, yeah, we're doing a shopping cart app. It's easy, but when you're doing other stuff, it's not so clear. And the thing about it is, some of these people totally are convinced, like, oh, you just do this and you'll have it all at the beginning. It's like, no, man, you get a first stab. You get a stab at it, and then you just keep stabbing. And then but the system, you design the system from the beginning with an understanding in mind that we're going to change this thing quite a bit until we find product market fit or the proper boundaries between these things. It's an iterative process, and let's not get ahead of ourselves.
So it's usually best to try and align the software boundaries with the different business domain areas. So what are?
I mean, that's easy to do. That's easy. I mean, it's hard to do. It's easy to say. It's easy to say, but hard to do in practice. Like that's
those business domain areas. So, for example, I work basically in what we tend to call nowadays hyper-local delivery, which means basically delivering from a local store near you, food traditionally, but nowadays all sorts of goods under an hour. All right.
Okay.
So that's a big domain. How might we divide that up into usable bits we can think about? So often there are natural seams. So we work in a 3-sided market, right? So there's partners, customers, and couriers. So obviously at a very coarse-grained level, we might want those. And we think about how we move work between them. So we might want some domain around fulfillment. And then we need to move money around. So we might want some domain around money, payments, finance, right? And then when I look at each one of those in turn, I might go, well, when I think about partners, I've got to think about things like information about the store, information about their catalog. And essentially, if I talk to an SME, I could probably begin to break down into things that they think of as separate subdomains.
SME is subject matter expert.
Storytelling, I'll show you
people that know about the business that you're trying to create tools to help automate.
In a second, that won't necessarily be insightful, but domain storytelling has a set of heuristics you can use after you jump to the flows for figuring out what represents separate subdomains within the overall domain you've been modeling. And
you're never going to be able to do that with a general model. You have some things to think about when you're splitting things up, but you're never going to have a general rule. And that's the part that I get to know. That's why I like this guy's stuff, but he's like also intimating like there's a general rule for all human problems, and I just don't think that's where our value comes in, is knowing all these rules and trying to implement or put a problem space into one of these rule spaces. Like, no.
And very traditionally, for Six Sigma people, value stream mapping, this idea effectively of slicing up into process.
That stuff all get to the Six Sigma, so we should have an amazing revolution in Six Sigma. Now that didn't really do it. It's just some ideas to think about, some things to consider. Come on now.
Steps, and maybe one that you want to think about, right? So most of you probably stayed in a hotel. There is a thing called the guest life cycle. The guest life cycle is effectively a value stream that talks about the process of staying at a hotel, from hotel selection through guest check-in, through occupancy to check-out. There are a series of process steps that you go through. And you can think about operational flows. In other words, I want to stay at the hotel. Environmental flows, please stop the minibar ahead of my arrival, right? So all of those are useful techniques. So domain storytelling, for example,
that's useful.
One of their examples, which is basically buying cinema tickets. We could easily, don't worry about the detail, go through this and ring fence where we think essentially there are the actions of people on work items tend to represent separate subdomains.
I like the event storming techniques to figure out this stuff, like what you're trying to do, a problem space you're going to get into. A lot of it's kind of obvious, and some of it's not so obvious, right? That's the difficult thing, is the nuance of where those things, where these boundaries are. This is also difficult to get right and hard to figure out, and you kind of have to like work through it. That's with multiple people, hopefully, if you can.
Domains. It doesn't really matter what technique you use whichever really you think works for you, but ultimately what you want to do is try and break up your domain model into useful subparts.
Right.
Okay.
And each subpart will be an individually scalable process.
As an aside, I don't tend to recommend event storming anymore, because event storming I tend to find is very focused on entities or aggregates.
Yeah, see, I like it. See, the thing is, he doesn't like it either, but he's also he has a specific definition of event storming that's probably some particular flavor of style of somebody who heard about event storming and they just put a framework around it. And is he examining the framework that it was studied? So he never talks about this. It's like, is it the particular definition of what you've encountered as event storming, or we're going to get everybody together that has a stake in this thing. We're going to figure out what the things are going on between these things so we can break these up into what Alan Kay talks mess about. His system of object-oriented programming, which is messages between these independently scalable, totally you can't look inside, opaque, except through the API. How do you split that stuff? It's super hard. You have to event storming is just one style of getting to the information. It's not going to be the way you do it. Like he says, if you pick one of these things, no, you're going to pick them all, man. All of them and none of them at the same time.
And tends to lead to what we call an entity service model, where effectively it's very CRUD-based, and I prefer to think in terms of processes instead. All right, but I've got my logical model.
Right, okay, I get it. He's like, instead of thinking that you have a REST, it's all going to be doing some REST API. You think about what the things are going to be at a high level, as if they're a human. And I have a video about this called the Universal Architecture, that you can replace where you have these people that are normally doing these tasks, you can replace them with processing units, and then you have to define what the processes are. And some of them are obvious and clear, and like in the case of a restaurant ordering thing, and some of them are not so clear. So that's where it gets difficult.
Things to be aware about my logical model is it will change. Right? The business will change. The business will decide to do new things, stop doing old things, try and change the way it does things. If you think about checking into your hotel, once upon a time, you'd have got a physical key. Then later on, you basically get a card, right? Nowadays, you might even get a bit of check-in on your phone, right, to access to your room and door. So some parts of it change. Interestingly enough, some parts of it are more stable. The process of check-in persists. It's just that the individual activities or tasks within that might change.
I mean, the task of check-in exists, but how you check in, the implementation of it might change. Yes, that's absolutely true.
But you will have to effectively constantly adjust your logical model for the changes to the business. Because tasks...
I mean, the implementation of the model? Because if you're going to go stay at a hotel, well, you're going to have to get the key to the door, unless you have an app that lets you bypass the front desk. That might be cool. Okay, what are you talking about, man?
Activities change more slowly. If you're thinking about subdomain modeling, tend to stick towards the processes if you can, because we will probably be doing check-in when hell freezes over, but effectively just the way we do it. The activities and tasks within it may basically alter.
Okay, implementation might change for what's going on, but the actual process of showing up, getting your key, getting to the room, getting the minibar, then staying there, getting whatever services are there, then doing the checkout, and then getting payment and all that stuff. Yeah, that's what we do inside each one is going to be specific to your business and your task and who the customer is you're trying to go after. Let's keep going.
But it's a constant gardening activity, right? You'll never arrive at a point where you can say, I've done the domain model, we're good for the next 20 years. Right? That's never going to happen. So
yeah, but business people really want that to happen. They really want that to be the thing. It's like, you have it now. You're at the top. You don't have to worry about it ever again. That's the dream, because they're a lot of business people are capitalists, and the capitalists, we dream of the monopoly. We would like to have one thing. It's why I talk about the micronopoly. I have a series of that. Why we want to have a monopoly in our space, because we can have a little moat where we can defend it and have our customers, and we serve them better than anybody else. We would like that, sir.
That's important for later, right? Okay. It's okay. You just need to be this tool.
Yeah, but the thing is, we don't get the moat. We actually have to keep mucking out the moat. We have to keep mucking out the moat, and the business people's like, maybe we can cut down some costs on this muck moating, moating the muck, mucking the, clearing the muck out of the moat. It's like, no, you have to continuously clean the muck out of the moat, man. Otherwise, it gets filled up with junk, and someone can just walk over and take our castle. We got to have a moat. But I don't like cleaning the moat. It's dirty. It's confusing, and there's alligators in there.
So we take that idea, and we tend to go towards the development branch. The development architecture focuses on the actual software module organization on the software development environment. The software is packaged into small chunks, program libraries or subsystems that can be developed by one or small number of developers. The subsystems are organized in a hierarchy of layers.
You hope that's the end result usually, but like putting people to do this together and get everybody on the mind space, you got to have APIs. You got to have some kind of whatever swagger, some kind of agreement where we can what we're going to be talking about, the messages we're going to be sending and receiving and expecting, and error conditions, and what kind of data you want out. And there has to be a boundary right there. It has to be a boundary. It has to be defined. We all have to agree on it.
Providing a narrow and well-defined interface.
That's the hard part. The implementation of these things, that they can take 1,000 different paths, but that API thing, and how do we update it? How do we deprecate it? How do we change it? How do we modify it for the future? How do we share this information on all the developers so we all understand what our different roles are for these different stages of this process?
The layer above it. So this is the point where we want to start thinking about how are we going to break up that logical model we just created into microservices. This is the view that says, I want to organize this into into units of software for delivery.
Okay, that's the trick, isn't it?
Remember our constraint earlier. The parts of the original problem must be solvable separately. So I think about that point there as the Goldilocks point, or the Goldilocks zone, if you like. That is the point we want to get to. And the problem is going to be that for any given business, exactly where that is going to differ.
Yeah, no kidding, man. Isn't that to the case? Isn't that true? You mean every business is going to have a different inflection point where, yeah, totally, man. 100%. Okay, keep going.
Point where effectively the number of components you have for the business problem you are solving is just about as low as you can get to reduce the intramodule dependencies without tipping over to get you intermodule dependencies will differ. So it's
how would you know when you're past that point, man? I mean, this is what you'd like, but it's sort of like when you're driving a car, you take the high lane, you take that high line, you're going to be low on the other one, but you're going to come high on the other side. It's like, how do you, yes, that's what you do, but how do you're there driving. It's like, when do you see it when it's high or low line? You're like, that's a bad metaphor, but let's keep going.
Fortunately, it depends problem. I'll give you a tip of the one way I think may help us begin to find that. But at the minute, it's a bit of a suck it and see. And one of our experiences at the minute is...
Suck it and see. He nailed it, man. He just said it in 2 little words, 4 words. Suck it and see. Yeah, 4 words. That is software development. A lot of this stuff is guesses. It's educated guesses, right? Based on experience. But it's always going to be a guess. And you're going to hope that you're guessing better than the other guy who's seeing your market and wants to take it over because they think they can do a better product than you can. But in the yeah.
People have to do it 2 or 3 times before they really find where that is. So typically,
yeah, there we go. Get some honesty in there. There's no guarantees on how long is this going to take to get this feature out. Hey, man, it might be 2 or 3 times. Well, that's not going to work for our VC. We're not going to get round C funding. Okay, I guess we can't cut some corners, but we're going to pay for it later. What do you mean? It's like there's no trade-offs, man. I mean, there's no penalty. It's always trade-offs. It's only trade-offs. We pay now, we pay later. We have to pay at some point. And it's, well, maybe we can defer it later. Well, it's just going to make it more expensive when you defer these things, man.
First wave of microservices is likely to be wrong. Okay.
Likely to be wrong. Exactly. Did they tell that to the microservice people when you're pumping out? I was like, well, microservices are going to be an amazing revolution in computers. Did you tell them that you're likely to be wrong a few times? And it may not even be fit for purpose. You may not even need this stuff at all. How are you going to find out? Well, suck it up and get to it.
The other indicator here comes from people like Neil Ford, etc., in software architecture. The hard parts, they talk about this idea of disintegrators and integrators. So integrators are things that force you to move something into one whole. Things like ACID transactions, right? If a transaction needs to be ACID, you don't really want to do it over a process boundary.
Okay, fair enough.
If you need to share data, how chatty a relationship of data you need to share between these 2 processes? Are you moving that data unnecessarily, right?
What does that mean?
Would you end up with shared code? right? Even if you did that and packaged it up. So those things force you to become a whole. Things that break you apart. It's too big. I can't think about it.
I mean, that's a good thing to think about. I'm glad he's not. I mean, I wish he'd give a little more detail, but how do you give details unless you're? There's just things to think about. So what? These aren't laws. There's integrators and disintegrators. I like how he puts a disintegrator on there because he's obviously a tech. He's obviously a sci-fi nerd. I'm pretty sci-fi. Like I gotta put disintegrator on a slide.
Right, change comes from very different directions. So in team topologies, they talk about this idea of the business domain bounded context, which is a bit of a mouthful. So bounded context is often misunderstood.
I mean, this is because it's too general. It's the idea. Check-in, bounded contest. A book, when you book it, that's a bounded context. Checking in, bounded context. Being in the wet bar and taking out a candy and registering it in the database, that's a bounded context. Ordering room service, bounded context. I mean, some of this stuff kind of falls out of it, but some people get things conflated together. Like, what was room service considered the mini bar as well, or can we split that up, or does that have to be together, etc., etc.?
Context exists in this development view. A bounded context is a collection of people, process, and technology that deliver software. It is your code repositories, it is your schemas, it is the code, it is the conversation you have as a team, it is the members of the team. Right? And the idea is that
too general.
Shares a view of a model. It consists of
a group that shares the view of a model, but like the whole model, all the models, or the individual model, they're responsible for. Is they gotta have more doing. So the people doing the wet bar, mini bar, computer program that sees that you picked up a pack of Coke at $17. Yeah, the guy that monitors that, they might have to be different skill sets and different stuff than the guy who's working in the restaurant. The little ticket comes up on the printer, and he grabs it off and gets it to the cook and starts making it. That may be a different process, right? But it may be the same one. Depends.
Boundary. The subdomain is the thing that you are modeling. In an ideal world, obviously, subdomains map to bounded context. But remember what we said. Domains shift. What the business does will change. And over time, what typically happens is bounded context and subdomains grow out of alignment, which you tend to think of as technical debt. And that's part of the reason.
Technical debt is not, that's not it. It's when technical debt, by the creator of the term, means the moment you find out a better way of doing something that you have, that the thing that you're doing right now is the technical debt. Until you can refine it, change it, throw it away, rewrite it, whatever, to get to adhere to the new thing, that is the technical debt. It doesn't mean anything else. But people make it out to be like old stuff laying around that nobody knows how to use, or nobody knows what it means, or just crufty old code laying around that can't be touched because it's too coupled with something else. Coupled.
Domain-driven design. In the large-scale software sections of the book, we talk about basic exercises like context mapping, where one of our efforts is to recognize and address that drift. Right. So they are two quite
good
separate
luck.
concepts.
I mean, but that's you're talking about also. That's Conway's law coming into effect again too. That's somebody's department. They got head count in there, man. You're telling people you got to get rid of the head count for the wet bar people because the restaurant's going to now integrate it into their process because they have a new system that lets a robot, which is the same as their waiter going up there, is going to change out the wet bar as well.
But it's this phase where we decide the bounded contexts. And so typically, one of the first things we will try is to say, okay, do I have a nice simple model where effectively those domains that I identified, the subdomains identified in a logical step, neatly map to problems that look at...
So this is some cargo cult shit here. AWS, this is Amazon cargo culting. There's no reason why they have to have that. It takes as many people as needed to understand that subdomain. It could be 2 pizzas, it could be 1,000 pizzas. As long as we have enough people to manage that process, that whatever that is, that makes it manageable for them, they're not complaining and they can control it, then that's what it is. It's not 2 pizzas. It has nothing to do with that. Well, it's 2 pizzas, so we can mark that down. That's $17 per head. Blah, blah, blah. It's like, come on, man. Stop with that stuff.
Because though they are probably code that fits in my head and roughly solvable by a 2-pizza team. If I have those nice sweet spots, they are ideal to be just a
code that can fit in your head. Whose head? Your head? My head? The new hire's head? Somebody from business person's head? What do you see these vague terms? This is what I can't stand it.
Microservice, right?
I gotta call it out. I gotta say something.
My head. Forces for change and replacement are cohesive. Probably.
What does that mean? Are cohesive? What does that mean? What changes together? Oh, okay, yes. If you change an API, you're gonna have to change it in other places. I don't know. Huh? Yes. Okay. As the requirements. Okay. Yes. you should do within the service boundary. We should not do these distributed transaction stuff. There should be within the service boundary, have its own database. There's Alan Kay's thing as well. That inside this, and I have an example on my GitHub about what he's talking about in Kotlin and in Java about books, a library system written with Alan Kay's stuff. And this is how it happens. ACID requirements are within the service boundary. That's awesome. I'm glad that I found that out on my own, and now it's been confirmed. That's awesome. That's great.
The ACID requirements are entirely contained within the service boundary, right? It's an ideal microservice. And this is really what the original paper refers to when it talks about splitting up services.
Does it mention Alan Kay? Does it give any credit to Alan Kay? Because this is exactly the stuff he was talking about. It wasn't even this boundary stuff he was talking about. The most important thing is not the boundary. It's the messages between them that create the system that's asynchronous. Let's keep going.
Organized around business capability, right? That's the ideal world. Wherever you have those, just say thank you very much and tick the box. The problem is, in reality, we find there are quite often more complex models. The code for the domain is actually a lot larger than one person can fit in their head. When I think about domains like courier assignment, which deal with things like network busyness, distance from restaurants, size and weight and load of the package, what type of vehicle you're driving, vehicle restrictions, the domain gets pretty complicated, right?
Yeah.
And so the question becomes, maybe I need to split that up because it's too big for one person's head, or maybe I need to put more people on the problem. So,
oof, I don't know about that one, buddy. Slam more people in there, more engineers, or are we trying to make this thing shorter in duration or longer? Never. Can we improve the quality of the engineers somehow? Can we improve the people's understanding as opposed to let's slam more people in there?
How do I kind of decide which one of those two?
See, managers love that. It's like, oh, you mean slam more? There's a point in the process where you need to increase headcount. All over it, chief.
I want to do, right? Well, one question is, could I find a scene that lets me split it up into multiple bounded contexts? If it turned out that checking into a hotel was really complicated, could I separate the bit that checks me in from the bit that generates my room key? It would seem fairly lightweight as interaction between the two, right? Because I'm just exchanging information about an identity and a room number. So I could look for these activities. And we said activities are more dangerous because they will change more regularly than processes, but I might be able to find activities within the subdomain that...
I mean, what's the difference between activity and process? Unknown.
...are separate. I want to watch the complex intermodule dependencies, right? And I want to make sure that those two activities are independently solvable. But I may create a dependency around transactions or shared data if I'm not careful about the way of doing it. So between that key and the check-in, probably there's no shared transaction. But I might have other scenarios where effectively I'm splitting an ACID transaction and I should avoid doing that. Right?
Definitely avoid that.
If I have multiple contexts, I have to define the relationship between those contexts. Right?
I mean, if it makes sense, avoid it. I mean, if you have to have two things that have to be going to some sort of sequence and both have to be there, and then you have a rollback. I mean, isn't that sagas? Is that what that's all about? I mean, you have to do all that kind of stuff if you have a distributed transaction, the saga type stuff where you back out the entities. So unless you want to get into sagas and you have a multi-step process, if you can put it inside of one service, that's a good idea. But if you have to have every three parts of it have to be completed, otherwise you roll it back. It says, well, you're gonna get sagas and you have to deal with all that stuff, which isn't that terrible, but you have to consider it ahead of time. The unhappy path.
Okay. And I need to be careful about breaking up so low that I get...
The unhappy path is much more important than the happy path. Because all the way the thing can go wrong. People don't like to hear about that. Wow. It shouldn't be going wrong at all. It's like, no, it goes wrong all the damn time. And we should be talking about the wrong thing. Because the right thing is very rare. It's like, yes, they got the right thing. We always talking about when things go wrong. That's wherever we come in. So we should maybe set the system up so we could detect when things are going wrong and be able to figure out where they're happening, as opposed to, well, just assume it goes right.
If I can't break it up, what do I do? Well, typically, what I might need to do is think about making it one thing and using modularity or components in process. So I don't reach for microservices. I say, actually, this needs to have modularity, but that modularity won't use a microservices approach. It will instead split it up into larger pieces. And that was named Macroservices by Cindy Sreedharan. She said, effectively, let's call this idea macroservices. And macroservices are not a monolith, because you may have many macroservices in your organization. And if we think, well, our rule about...
This is just services? Let's keep going.
Breaking up our monolith is it's larger than a 5-pizza team. Maybe there's some sweet spot between 2 pizzas and 5 pizzas.
Oh my God.
We deliberately use that measurement because it's not an exact number. Where effectively we say, this is larger than a microservice, but it's not so large I necessarily am forced into breaking up to become basically a set of microservices out of the monolith. So I'm not creating a new monolith, I'm just creating something that's larger. There's going to be a cost to that. And the cost is those teams are going to have to work quite closely together, and we may get some release dependencies between them.
Maybe,
so they may go a bit slower. They may need to have a mono repo. They may need to declare they've got a single CI boundary because they may be sharing data and maybe sharing across a schema. But in principle, the dependency
across a schema,
management between them may become much easier than if I tried to break up what was a cohesive domain and it's quite complicated across multiple processes. Because that process...
Fair enough. But it depends on what you're doing, right?
Boundary I've introduced may cause me more pain than the problem effectively of having to coordinate release cycles across that team.
Correct. So how do you decide that? Where's that boundary sit? Where's that line hit? Taste, your experience, curation, seeing other things like this, guessing, realizing you're not gonna get it right, like you said earlier. We're probably gonna get this wrong. We have to cut this up in a different way. Management's not gonna like that. Management's not gonna like hear that. It's like knowledge work, man. This is what we do. We experiment. The experiment doesn't work out. If we don't do the experiment, we're done. We're coast. So we have to do the experiment. Now we would hope the experiment goes well, but if it doesn't, it's not the end of the world. And we have given time and a headspace that we're going to try out and do something else.
And this is typically, I think, where some people struggle because they have said, well, these things must be 3 or 4 microservices. They then feel the pain and they say microservices doesn't work. I want to throw it all away and become a monolith. And what they really need to...
That's absolutely what happens because of how this has been sold to them. They weren't told all these other things. You might have to do multiple times attempts at this thing. You might want to set your system up so this is monitorable and all that stuff. They weren't told that. It was like, just get on AWS and start ramping that. Just cut your system up into 5,000 pieces and you're good to go. They did it and things aren't going so good. They're not going how you said. Well, we got another course for you. We got another class for you. You can get us to the gold, the platinum tier, and we'll get you some support.
Was somewhere in between, a bit like Prime Video, where they went more into a macro service.
Awesome.
The other problem you can face, although it's less common than that one we just described, is where effectively your domains are tiny. And you may worry that effectively you're now going to generate huge overhead for one of these services being independent that isn't really justified by just making them fully independent. And you may say, okay, well, hang on a minute, I'd probably give 20 of these to this one team anyway because the cognitive load of it's very small. And maybe they might find that organizing 20 of these things is actually a bit harder than actually trying to join them together. So could we look for ways to actually join them together in a single bounded context? Remember, a bounded context is not a domain, right?
So how do you decide where that goes? He skipped over. He went over it, said it real fast because the managers don't want to hear that. This is an experimentation thing. And they were probably going to be wrong. And that we hope the experiment is fruitful, but most of the experiments, like all science and like all knowledge work, it's going to be wrong most of the time.
There is a mapping between domains and bounded context. They are not the same thing. All right, so we could basically say, okay, well, is this domain really independent?
That's how we get to it, is by being wrong, by experimenting. We'll eventually get it if we're given enough time. If we don't get Series A, Series B, Series C, we'll eventually get it. But it's like how fast, how long? A lot of it's just luck, man. A lot of it's luck, a lot of it's timing, a lot of being in the right place. Right? Sometimes this is like low-hanging fruit, a new market, a new space, a new thing, and you just happen to be there at the right place, right time, roll the dice at the right moment, and you came up 7s, and you just won the pot.
Does it have separate reasons to change? That's probably a bad candidate for joining together. But are the behaviors about the same work item? Well, maybe if we're just cooperating on the same work item, maybe we could be joined together. Are we talking to ourselves? So I've seen instances where there's 2 teams that own 2 tiny services, and all they do is talk to each other. Well, why aren't you one thing?
Great. Good. This is good. This is good stuff here. This is helpful.
It may be that between these small things there's an ACID transaction. Well, we don't want to break that up. So maybe move them together into one service.
Great. This is useful. So this is the kind of thing I would expect architects to have, this type of decision matrix, not this specific technology baloney, but this kind of things to consider. When do you put it together? It's like, you're not going to know when. It's just going to be this kind of stuff and giving a shit.
And will we weaken cohesion, effectively, if we treat them as a separate context? So maybe that's a good reason to pull them together. And if we leave them alone, will we suffer from the nanoservice problem? So sometimes your bounded context is actually multiple domains. Okay.
Agreed.
Remember, we identified that our domains will change. So the problem here means that also means that the microservice partitions, the fracture planes that we choose, will change as well. Owning microservices is a constant activity. There is never a we are done.
In general, in software, software's never finished, by the way. And this is business people really need to understand this. Like we're never done. And software projects are just abandoned. They're never killed or shut down or whatever. They just like stop running. I mean, you may shut it down, but it's like we may start it up again. They're never completed and they're never killed. There's just bits sitting out there that wants to be processed by somebody at some point, maybe. And if not, well, yeah, right. They're software projects are abandoned. You have to continuously maintain them because everybody else is doing this thing. They're moving up too. And if you stay down here and you think you're just going to keep going, it's like, no, that's not how this works. You're never going to be permanently at the top either. You always have to like continuously look at this stuff and care about it.
Unfortunately, as your domain changes, you will have to repartition and change things. Hence the requirement about replaceability. The more replaceable something is, the easier it's going to be to shift those boundaries.
Correct. That's difficult to find out, and it's an experimental thing, and things are going to pop up you didn't think about, and then or a new opportunity that was like right there, and you just happened to be at the right place at the right time, and you switched it over to that little thing, and boop! Wow, overnight success. It took about 20 years.
See, let's call it originally when your components are served as remote communications, then refactoring is much harder than within process libraries. So essentially, the things that you separate should be replaceable and quite distinct and focused on more process boundaries, right? And where things are tight together, maybe put them inside a microservice where it's easier to refactor them. I haven't got time to dive into it. I think one of the most interesting developments in this area, though, is Barry O'Reilly's residuality theory. If you haven't heard of Barry's stuff, you can check it out on YouTube.
What does it say? It says a hyperliminal. What does it say here? I'm going to read it because this guy's fun. A hyperliminal system is a system where complicated ergodic ordered system executes inside a complex non-ergodic disordered context. It is the job of the architect to design a structure for the complicated system that will allow it to survive as the complex context around it changes and moves. Good luck with that, buddy.
He's got a book on LeanPub. Barry, one of the things Barry's offering the promise of is the ability for us to effectively stress our models in order to see what kind of changes we can make to make them survive business changes in the future. So it works.
Well, yeah, that's the dream, isn't it? So he's trying to do this thing where you would always be able to know what the users want, the solution they want, the problem that they're having, that they have today in every single niche from here on out forever by predicting which way the chaos is going to move. Yeah, that's a dream. That's not possible. All you can do is respond to it as a human being and apply your creativity to it where it makes sense. You're not going to be able to predict in the future where things are going to change. You can look back and see where things have changed, maybe get some insights in the future, but if you're still doing the same thing we did before, well, that's not really software development. You're just copying code. We're trying to do something new. Trying to keep a moat up for our customers so I can continue to solve their problems for them in a profitable way. What the hell? You're never going to be able to predict that stuff. Come on now.
On the theory that we can cluster whole numbers of changes of producing the similar force for change on our service. So maybe we can produce something that better survives business changes. So his idea is he calls this a hyperliminal system, and essentially what he means in that
hyperliminal system. Hold on, let me see what else. Okay, so ergodic is of relating to certain systems that, given enough time, will eventually return to the previously experienced state. So like a Ouroboros. Okay, what is he? And here we got liminal, of relating to or situated at a sensory threshold, barely perceptible or capable of listening a response. Okay. I appreciate the poetry, sir, but this is a confusing thing. It's like, I want to predict the future somehow. It's like, you're not going to be able to do that, man.
Quote is, the real world is messy, chaotic, and not easily structured.
Absolutely.
Software requires structure, we have to be deterministic about
the solutions we want to provide people on these machines. We do require some sort of structure to provide a solution for their problem. Yeah. Why do you have to be so flowery poetic? Let's keep going.
And it's somewhat rigid. These two forces are in opposition to each other. We are trying to make a structure around something that is unstructured.
Correct. But that's the value we're bringing. We're bringing order to the chaos, and for someone else who doesn't have the capability or want to, whatever, or so got something else they're trying to do, and we're going to assist them in that. Yeah, it's going to be super chaotic because humans are super chaotic. We have all kinds of wants, desires, needs, cultures, languages, perspectives, outlooks, things of views of the future, worldview, what's real, what's moral, what's ethical. Come on now.
And so it always breaks down in the end. But maybe we can figure out how it would break down and use that as basically a way of making something that's more resilient to those fractures over time. It's a very interesting...
No.
field, but I haven't got time to go into more depth today.
Yeah, because it's a pipe dream that will never be solved. I understand the want and desire and the attempt, but it would be more. I think you need some philosophy, because there's certain things that just you're not gonna be able to calculate ahead of time, because literally the amount of ways that chaos can change is infinite, and the ways that we can adjust it and manage it are finite. So infinite's always gonna be finite no matter what.
Yeah, some of this stuff is complicated. Processes.
Great.
So
a lot of it's because it's based on subjective parameters that have to do with all the things I just mentioned about the style and taste and culture and ethics and all that stuff. Yeah.
This is when we effectively take that bounded context which we have developed and we say, okay, how am I going to represent this in terms of processes? Processes are not bounded contexts. They are not subdomains. They are how we effectively create an executable unit for our software, right?
Okay, so what are you talking about? A software process? A system process or a business process? You're flipping these things back and forth, confusing the hell out of us.
It's a grouping of tasks that form an executable unit. Processes represent the level at which the process architecture can be tactically controlled, started, recovered, reconfigured, and shut down.
Okay, a process is a grouping of tasks that form an executable unit. What does that mean? Processes represent the level at which the process architecture can be tactically controlled. Started, recovered. Okay, this is all operating system. Is that what you're talking about? Not business. Can the yeah, okay, let's keep going.
Okay. It's also about how we interoperate. So in a modern
I just did a video on the 12-factor apps. Okay. Interesting. That's the new thing that's going around. 12-factor apps. It's pretty good for web apps and cred apps, but everything else is like, okay, these are all interesting things to think about, but these aren't all applications are basically this. Like, no.
In a modern world, we want to be application-centric, not infrastructure-centric. By that,
application-centric, not infrastructure-centric. Okay, I'm not sure what that means.
I mean, we care really about product development teams being able to say, here is my application, here are some things I need, platform provide them for me. Certainly at scale, you don't want teams to having to deal with provisioning their own infrastructure, etc. That tends
why not?
to mean you want to think about 12-factor apps, and we'll come back to that in a little bit. We also need them to communicate. You make some choices between asynchronous and synchronous. I would tend to choose asynchronous.
Well, yeah, I mean, synchronous inside the process, but asynchronous outside the process, or the task, I'm talking about process like the business process. It's like, because the universal architecture I talk about, like when you have people at a desk, it's like you call them up and they take a message for you, and then they give it along to the processor when they're ready, or the processor picks it up when they get the chance. So it's like you can create humanized views of these complex architectures, and then make sense out of it, and where you can split these things up appropriately. Let's keep going.
Your mileage may vary. Even back in the day, people were carefully warned, microservices are not single processes. You may have more than one. When we look at 12
okay,
factor apps, there's some clear guidance, right? Effectively, you have diverse workloads. So figure out what other process types you have. So typically, you may have a web workload.
Are you talking about Kubernetes?
Worker workload might be dealing, for example, with Kafka running in partitions. Your scaling of the worker that is reading from Kafka partitions is entirely dependent on queue theory and number of partitions. You are scaling for totally different reasons to the reason you are scaling the web component. Your Kubernetes web component may well scale on CPU, but you want to be scaling on queue length or latency for those one thing running against Kafka. You don't have one process. You divide it up into multiple processes, and that tends to be referred to as your process formation.
Okay.
There are some integrators and disintegrators here as well, very similar to what we had before.
Oh, disintegrators, my favorite.
But essentially, if you think about a microservice ending up being a 12-factor app, and you think about a macroservice as being maybe one or two apps, or maybe some kind of microkernel architecture with plugins, then effectively both of those map
these are all arbitrary
to a process formation, not a process. Then we get to the easy bit, the physical bit. And the physical bit simply says, what I need to do is figure out how I put those processes into infrastructure. So the point
this used to be a major big deal, but now it's just like you're going to put it on the cloud somewhere. There's your infrastructure. And where are you going to provision the servers? Okay, that's your infrastructure.
Where infrastructure should emerge. And essentially, that's the point where you worry about Kubernetes and Lambda.
Well, I don't know about that. I think you might want to think about it earlier than that. Your whole thing's been based on that. I actually like his stuff. I like how he's bringing these things up, but again, there is this tendency for the conference-driven development crowd to like, this is like this and this is like that, and when a lot of it's super vague and open to nuanced interpretation, and it depends, because it does depend. All right, give me a like and subscribe. Go give those guys a like and subscribe. they do good work over there.